alcohols. Reactions involving reactions involving cleavage of or OH. That is this. Cleavage of ROH. So you do understand in what conditions the group is possible to cleave. Likely inductive effect. You do understand H C H H O H. This one is 1 degree alcohol. Then another one is R C R C H O H. 2 degree alcohol. Then third one is R C R R O H. This one is 3 degree alcohol. In 1 degree alcohol, low inductive effect, poor inductive. Poor inductive. Here is very high inductive effect. High inductive effect. So, when alkyl group will provide electron to carbon, this to this alkyl also this, the electron density increases at this carbon atom. If electron density increases, then it is quite easy to get free OH ion. So that means plus I increases, plus I inductive. Due to plus I, it is easy to remove. Already you know when we have done example C2H5OH SOCl2, the OH group is removed from here, and the HCl and SO2. So what you got? C2H5Cl SO2 plus HCl. Halo gas. So this is removed by the reaction this. Second, 3 C2H5OH plus PCl3. So here is inductive effect. So you will get 3 molecule C2H5 Cl and then H3PO3. When we were doing preparation method of haloalkanes, the same method we have applied here in case of preparation of ethanol using thionyl chloride, thionyl chloride. It will react with ethanol and you will get easily by removing OH group by the same method. If you will take tertiary, this is the primary. If you will take tertiary, the reaction will be faster. Okay. Another one is acidic dehydration reactions. First, then another. Then acidic dehydration reactions. Acidic dehydration reaction. Now, in such case, what will happen? Acidic dehydration reaction. That is the elimination. If you are taking C2H5OH plus H2SO4 concentrated H2SO4 443 Kelvin temperature, then you will get C2H4 plus H2 by this reaction. Reaction mechanism, very, very important. Very important reaction. Several times asked in the board examinations. Reaction. No. In this reaction mechanism, if you know about the beta elimination reactions, I already explained in the previous classes. So we have to write this C H. Here is C H. We can write this in this way. Then here is first step is called protonation. That is called protonation. This proton will come from H2SO4. Lone pair electrons of this one. It will come. That is the electrophilic attack. As I explained in the starting of chemical reactions, then you will get C, H, again H, C, H, and here O, H, and then one more H. This one. So this is called protonated alcohol. This is called protonated alcohol. Now this protonated alcohol, step second. This protonated alcohol, if it will take electron from this, so in such step, CH, H, H, and U, OH, it will go. It will turn into protonated carbocation. Let's see. H, C, this one. That is called protonated carbocation. Protonated carbocation. There are two steps. Again, I am going to repeat. CH3, CH2H. It will protonated by taking proton. That is electrophilic attack. As I explained in previous classes, you will get the protonated alcohol. This H will agree that this oxygen and give its proton. It gives positive charge. So next CH3, CH2OH. This water molecule is removed by taking this And you have to write here minus H2. So proton and protonated carbon atom. In third step, step third, it is called deprotonation. It is called deprotonation. No deprotonation. In case of deprotonation, one thing happens, CH, H, H, C, H, H, this one. So, this is alpha carbon, this is beta carbon. Always keep remember where it proton will goes. This one is alpha carbon, this one is beta carbon. Beta carbon. So it will get electrons from this hydrogen and it is moved out. You will get HC. H electron density here. 1 C H and 1 point. Now this positive negative charge decomposition and form a double bond. So accordingly, you will get CH2 double bond CH and proton is free. This is this proton comes out. Lastly, from H2SO4, HSO4, it will get this proton and you will get again retained H2 SO4. Again, C11, reaction mechanic protonation. This is not easy. Direct reaction H2SO4, you will get C2H1 and then H2. If you will apply here CH3, CH2S, that is electrophilic attack, you will get CH3, CH2OH, then CH3, CH2, OH, and one more proton, it will get. And after removing one water molecule, the proton is transferred to carbon chain at alpha carbon atom. In third case, from this beta carbon, it will give electrons to carbon and get free in the form of proton here, like this. And CH2 double bond CH2 proton is free. Okay, this is then H2SO4 retained. This reaction is called beta elimination reaction. It is called beta elimination. This is called beta elimination. Because beta elimination. Okay. Now, how this happens? How elimination occurs? As I told you, this reaction, tertiary, secondary, and primary. The most elimination is quite easy in this one. See, we are taking three kind of alcohols. CH3, CH2, OH, concentrated H2SO4, 443 Kelvin temperature. Then you will get CH2, double CH2 plus H2. Yeah. 31 degree alcohol. Now, second case, CH3, CH3, CH4. This is 2 degree alcohol. And for H2SO4, you can remove this easily. Then less than this temperature, and very few temperature, it means 373 Kelvin. Then we will get here CH3, CH double bond, CH2, plus H2. As I told you, always water molecule moves up by losing one OH group. In third case, vector C, CH3, C, CH3, CH3, OH. These are 3D alpha. The same mechanism I told you is applied here, same mechanism. According to this reaction mechanism, you can do this. H2SO4, but at the room temperature, at least 25 degrees Celsius temperature, you can convert this CH3, C, CH3, CH2, plus H2. In all three cases, primary alcohol, 2-degree alcohol, 3-degree alcohol. The reaction is quite easy with the 3-degree alcohol because this reaction happens at 25 degrees Celsius. No, like first reaction occurs 443 Kelvin. Not like that 373 Kelvin. This reaction happens at 25 degrees Celsius due to coincident effect as I explained in reaction mechanism. Clear? Now, one more reaction for this. I am giving you how this happens. Deuteron, Deuteron, CH3, CH2, CH2, 2H. Here also same protonation. This proton if you attack here and CH3, CH2, 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 and then OH2. In short. Again, dehydration. It will gain electron from this carbon chain due to positive inductive effect. Then you will get CH3, CH2, 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 and then H2. Okay. But this carbocation is not stable. This carbocation is not stable due to very small hyperconjugates. So, unstable due to only to alpha H, hyperconjugates. So, what happens in this case? I am going to write here CH3, CH2, CH2, CH2. Here, hydride shift. In hydride shift, that's the H. We can write this way. This will take electron from positive sharing and it will go to here. That is negative H negative. H negative is hydride. That is called hydride shift. In hydride shift, it will come here and we will get here CH3, CH2, CH double one, CH. So CH, CH3. This is stable carbocation We got 3 and 2, 5. This is stable carbocation. Stable carbocation. From this stable carbocation, now this hydrogen is easy to make symmetrical. So this is alpha and this beta. Always alpha carbon is considered which carbon contains H positive charge. That is called alpha carbon. Now I am going to modify this part also. You have to add this. This H, it will give electrons, that is H positive, read, and you will get CS3, CS, CS, CS. That is a major alkene. Whereas minor alkene on the base of this minor part CH3, CH2, CH2, CH, and CH2. This is the minor. This is a minor, this is a major alkene, this is a minor alkene. So it will you get by this method 95% major and 5% minor. Got it? One more challenging question, generally asked in this case. Where there is the arrow, you have to write accordingly. You have to write accordingly. This is the process, unstable. Due to only two alpha. Then it turns into hydride shift. Hydride shift by hydride shift required to provide stability of any carbocation. If we here hydride shift will take place, so it will give the stable carbocation. In next. CH3, CH, CH3, CH2. Here is concentrated H2SO4. Then what you will get, how this happens? In this case, the compound you will get CH3, this. Here is the branch, the main thing I would like to explain right now. Mechanism. With the help of mechanism, you will come to know the right process, how this reaction happens. CH3, CH, CH3, CH2. First of all, what is the process? Protonation. By taking lone pair electrons from OH group. This is called electrophilic attack. This is called electrophilic attack. Then you will get CH3, CH, CH3, CH2, OH2. No. Next step, dehydration. First step, protonation. Next step, dehydration. In such case, the same carbocation CH3, CH, CH3, CH2. It will gain electron from the carbon chain due to positive ion, positive electron. Then here is minus H2. minus H2O. CH3, CH, CH3, CH2. Unstable carbon atom. So this is also methyl C minus C. That is methyl C. Methyl C. In this methyl C, again same method. This CH3 will come as carbon atom. The compound will be CH3, CH, CH, C. This. Now here, proton moves out and we will get CH3, CH, double bond, CH, and C. Here is methyl C and deprotonation also takes place. So by this reaction, you will get symmetric and symmetric, symmetric and right. Next is on mixing of two alcohols, 400 something Kelvin degree Celsius. There are two different kind of mixings, symmetric and yeah. If H2 SO4 is applied with alcohols, in large amount, and H2SO4 in small amount, it gives ethers. Very interesting. Like C2H5OH plus, we can write here HO C2H5. The process occurs in presence of H2SO4. Same, but temperature 413 Kelvin. In previous reaction, we have taken 400, then 43 Kelvin. Here is 30 degrees Celsius less, then you will get here. OH will move down. C2H5O C2H5. There is diethyl ether is a product, right? So this is the SN2 kind of reaction. As earlier reaction was SN1, these reactions are SN1 reaction. If someone asks you, the elimination, this reaction is SN1 kind of reaction. Because in these reactions, carbocation formation takes place and you will get the desired compound. But this is SN2 reaction. This is SN2 reaction. SN2 means nucleophilic substitution reactions. Both reactions are very important, can be asked, but here is the reaction mechanism. The reaction against the reaction occurs in single step. The reaction occurs in single step. Like mechanics. All mechanics are very important. Water and CH3, CH2, OH. As I told you, OH, electron density. In presence of HI, you will get the electron field reversible. CH3, CH2, O, H and H. You can write this. So that is protonated alcohol. Protonated alcohol. Now this protonated alcohol again in step 2, you will take CH3, CH2, OH. This protonated alcohol will react with ethyl alcohol. H, O, C2, H1. This will attack F. This water molecule, it will form a complex. It will form a complex. The complex compound will be on the next slides. You will get C2H5 O and then H, then again C2H5 O. This is a complex compound. So this is transition state. It is unstable, transition state always. Then it will lose this water molecule. This water molecule moves out. This is the proton here. And this proton shifted to this place. Then you will get C2H5O, C2H5 plus H2. And in next step, this proton is filled. So this is the SN2 reaction mechanism. By this process, Williamson synthesis of alcohols you will get. You will get. Only primary alcohols can do this. In case of secondary alcohols, in case of if primary alcohols are in small amount and pass through and pass through chromic acid, CHRO, chromic acid, then H2Cr. This is called chromic acid. You will see different result, then you will get ketones. You will get ethanol, aldehyde, ketone, like CH3, CH2OH, and H2, CrO4, in such case you will get CH3, CH. Okay, and on further oxidation, you will get CH3, C. This one is ethanol gas. This is called ethanol acid. One of the application method of ethanoic acid is acetic acid from alcohol. Sometimes such kind of questions can be asked, convert this to this. If somebody will ask you, convert ethanol to CH3. In this case, the reaction is applicable. You can apply these things and you will get this. Not only this, you can take a proton 573 Kelvin oxidation takes place. You can take KMNO4. You can take potassium dichromate. Then lots of oxidizing agents you can use here. Okay, likely secondary alkane. CH3, CH3 is the same method, H2, CrO4, you will get CH3, CH3. That is propanol. Propan, you will get. So I mean to say, the reactions are initiated by H2Cr. Okay. Now reaction with propane. Reaction at 573 Kelvin temperature. The reaction will be same like chloric acid. C2 plus 5 then Cu 573 Kelvin temperature. You will get CH3, CHO plus dehydration. In the second case, CH3, CH3, CH4. Then you will get copper 573 Kelvin temperature, CH3, CH3, CH3. On further oxidation, CH3, COOH, and CO. Such kind. Here, further oxidation, then CH3, COH. You will get pure. Okay? Now, please, re-enter again.